Welcome back. In my previous videos, I have covered the basics of linear equations and I have completed activity 10 and 11 from SpringBoard Course 3. In this video, we are going to complete activity 12 from SpringBoard Course 3. Activity 12 is all about slope-intercept form. The formula for slope-intercept is y equals mx plus b, which is written right here, which we have covered in our previous videos. Slope-intercept form shows linear relationship between two quantities, and those are x and y. In this activity, we will deal with two different types of data, and those are called discrete and continuous data. It is shown on page 148, and let me show it to you guys right here. So one type of data is discrete, the other one's continuous. And discrete means having a fixed number of values. So this should have a fixed number of values. And an example of discrete data is the number of students in a class, because you can't have half a number or 3/4 a number of students. Continuous means data that can take any value within a range. So that's just data. And an example of continuous data is the height of students in a class. In continuous data, you draw a line. So in continuous data, you draw a line, while in discrete data, there are breaks between the line. So in this, there are breaks. Okay? So, we will be doing activity 12, lesson 12-1, page number 147. So, let's start with number 1. So, number 1, let's see the scenario of it. Number 1 scenario said, Owen's water bottle leaked in his book bag. He did the following experiment to find how quickly water drains from a small hole placed in a water bottle. So we're not going to do this whole experiment. Instead, we can just use fake data to make our life more easier. We don't have to do this. So my fake data I used was 10, 5, and all this was zeros. You can use the same data too to just continue to practice with me. So then I graphed the data from the table to here. For number 2, it says graph the data, so I did that. So we'll move on to number 3 now. So number 3 says, does the relationship between time and height of the water appear to be linear? Explain your reasoning. So it does appear to be linear because we can see it forms a line. So yes, it is linear because it has a constant difference of -1. We can see that because 10 is 0 and 0 is 10. So if we do that, we'll get so if we solve for the slope, we'll get the slope of -1. So let's go on to the next page, and that is page 148, lesson 12-1, activity 12. So in this space, it talks about discrete and continuous data. So let's read it so you get more understanding of discrete and continuous data. Discrete data are data that can only have certain values, such as the number of people in your class. On the graph of discrete data, there will always be space between two possible values. Continuous data can take on any value within a certain range. For example, height. On a graph, continuous data has no breaks, holes, or gaps. That's kind of what I said in the beginning in the introduction. So, writing math. Let's read this tip, which is over here. So this tip says the y-intercept of a line is written as an ordered pair. Like I told you guys before, that you should never write the y-intercept as just a y value. You should write it as an ordered pair, where y is the value of which the line intersects the y-axis. So let's go on to number 4. Number 4 says, are the data you collected continuous or discrete? Justify your response. So let's go back. So we can see, since time can never be discrete, you can have 1.5 of a second and this, that. So we know that this is continuous, and also I drew a line right here. So, and since the line has no breaks, it is continuous. So you're continuous because you can take any value from 1 to 10 seconds. Like I just said, you can take 1.5 seconds. So let's go to number 5. Number 5 says draw a line through the points on your graph. So this just proves my point back there. So if we draw a line, there will be no breaks. So it has to be continuous. So this proves my number 4, this sentence right here. Draw a line. And let's go to 5a. 5a says find the slope of the line. So I already calculated from before that the slope of the line is -1. So I just put that over here. So the slope of the line is -1. And determine the y-intercept of the line. we can do that by, let's go to the previous page. We can do that by seeing where it crosses the y-axis. It crosses the y-axis at 0, 10, so that's our y-intercept. And 5C says, describe the meaning of the slope of the line in this problem situation. So the meaning of the slope would be, for every second the height of the water decreases by 1 centimeter. So every second that passes by, the height of the water decreases by 1 centimeter because the water leaks down the hole. And 5D says, describe the meaning of the y-intercept of the line you drew in this problem situation. So the answer would be, the water level at the beginning of the experiment was 10 centimeter, and that would be the meaning of my y-intercept. That would be because I put 10 centimeters into water and it kept on leaking. So let's move on to number 6. Number 6 says, write an equation that gives the height of the water h given the time t. So first we should just put the y-intercept over here and the slope over here. So h equals 10, subtract t. We don't need to put 1 here because 1 doesn't make a difference, and we usually don't write 1 over here. So let's read these math terms before we continue 7 and 8. So the coefficient of a variable is the number being multiplied by the variable. So 1 would be the coefficient. The constant term is the term without a variable, so 10 would be our constant term. So let's go to number 7. Number 7 says, how does the coefficient of t in your equation relate to the experiment? Be certain to include appropriate units. So the coefficient of t is same as how much height of the water decreased per minute. So we can see that because it says height of water per second, so that's how I got my answer for that. So let's go on to number 8. Number 8 says, how does the constant term in the equation relate to the experiment? Be certain to include appropriate units. So the constant term is the same as the water level at the beginning of the experiment. We already know that from 5D. So let's move on to the next page, which is page 149, activity 12, lesson 12-1. So number 9. So number 9 says, find the slope of the line that passes through the points in the table. So this is the points we have to find the slope. We can find the slope by calculating change in y or change in x, and I found that this was the slope, negative 1 3/4. So let's move on to check your understanding. So let's read this problem situation before continuing. The problem situation is, Ben's Bell, a community service organization, began hanging ceramic wind chimes randomly in trees or bike paths and in parks around the country. In 2003, a written message on each bell asked the finder to simply take one home and pass on the kindness. 1,000 bells were hung in 2003. The number of bells increased by 2,000 each year after 2003. So number 10 wants us to complete the table below to indicate the number of bells that were hung each year. So this is our initial value, and then for every year passed, there were 200 more bells hung. So we just add 200 to the number right here. So number 11 wants us to graph the data on the grid below. So 0, 1,000, 1, 3,000, and then you can just graph it all the way. And number 12 says, is the data continuous or discrete? Justify your response. So it would be continuous because first of all, it increases every year. Plus, you can take 2.5 years, and then you can see that the answer would be 6,000 bells. So it's continuous because years can be divided into a half a year too. It's not that you only have to take a whole number of years. So let's move on to number 13. Number 13 says, use the data in the table or graph to write an equation that gives the number of bells distributed n given the number of years since 2000 and 2003 t. So our equation would be the y-intercept plus the slope and equals n. So 1,000 plus 2,000 t equals n. So that's our equation. And that's how we got it. So number 14 says, using the graph in item 11, this graph right here, determine the slope and the y-intercept of the line. what do these values represent in real life situation? So we know the slope is 2000 because change in y or change in x is 2000, and the y-intercept is 0, 1000 because it intersects the y-axis right here. So the slope in real life means the number of belts that increase each year, and that number is 2000. And the y-intercept means the number of belts starting from in the year 2003, and that number is 1000 belts. So let's move on to the next page, which is page 150, lesson 12-1, activity 12. So this is the lesson 12-1 practice. So let's go to number 15. Number 15 says, graph the data in the table. Find the slope of the line created by connecting the data points in the table. So first we have to graph this data and then find the slope. So we can find the slope first and then graph the data because then it will be easier for us. So we found the slope of -0.5. And then you can just graph these 3 points in here and then make this continuous arrow like this. So let's move on to number 16. Number 16 says, examine the table of values. So to examine this values, write an equation that gives you a value of y for any given value of x. State the slope and the y-intercept of the line that the situation represents. So basically, what we know that the y-intercept, so we can find the slope. So the slope is of the line is gonna be -5, because if we take these two values, we can see that the slope will be -5, and the y-intercept will be 0, 0 because it's right here. So our equation would be y equals -5x plus 0. So we're done with 16, and let's move on to number 17. So number 17a. Number 17a says, find the slope of the line in the following graph. So you find the slope in this following graph. The slope would be -4 because you can take these 2 points right here, this point and this point, and you can see the difference in vertical change is 4 and the horizontal change is 1. So that gives us -4. And the y-intercept of the line would be 0, 1 because this circle right here is our y-intercept. So let's move on to 18. 18's problem situation is, my car rental charges $15 per day to rent one of its cars plus an $8 service charge. So 18a wants us to write an equation that gives the total cost y for the number of days x the car is rented. So this is our variable cost, this is our fixed cost. So if we combine that together, the equation would be 15x plus 8 equals y. So let's move on to 18b. 18b says, state the slope and the y-intercept of the line that your equation represents. So the y-intercept would be 0, a, and the slope would be 15. We can figure that out by the equation. So let's go to 19. 19, let's see the problem situation. So the problem situation is, Marilla is driving a distance of 100 miles. She drives at a constant rate of 60 miles per hour. The equation that represents the distance she has left to go is y equals 100 subtract 60x, where x is the number of hours she has already driven. So first we graph the equation, and and this is how our equation looks like graphed. So, and then 19a wants us to graph. So 19b says, state the slope and the y-intercept of the graph from part A. So our slope is -60 and our y-intercept is 0, 100. We know that because this is 100 right here and the slope is -60. And 19c says, explain what the slope and the y-intercept of the line represent in this item. So the slope is -60, and it represents for every hour she drives 60 miles to her destination, and 60 miles is cut from her driving time. 60 miles is cut to how much she has to drive. So that says -60. And the y-intercept is 0, 100 because that is the distance she has to travel in total. Okay, so let's move on to the next page, which is page 151, Activity 12, Lesson 12-2. So, there's a really important vocabulary in the learning targets, and that's proportional relationships. So, proportional relationship, the graph passes through 0, 0, or the origin, and if you double x, you also double y. So, this is a really important term, so you should circle it and know the meaning of this. So, let's read this before we continue. So, slope can be seen visually as the length or the steepness of a line. Using a graph, one can determine the slope of the line as well as the y-intercept. One can also compare the slope of different lines by considering their graphs or their equations. So, let's see what number 1 wants us to do. Number 1. For each linear equation table below, complete a table of values. Graph using different colors for each line, determine the slope. It's okay if you don't have different colors, just label them. So that will be, if you don't have different colors, just label them like this, A, B, and C, so you know which graph is which. So let's complete a table of values. So from this, we can determine the slope is 1. So let's just write the slope. From this, we can determine the slope is 2. So write the slope as 2. From this, we can determine the slope is 4. So write the slope as 4. And then you can just complete the table of values. Put in x. And then put in x here. And then you can complete the table of values. Plus, you can graph it like this. So based on these table of values. So let's move on to the next page. Let's move on to page 152, lesson 12-2, and activity 12. So let's see what number 2 wants us to do. Number 2 says, how does the slope be found for each linear equation relate to the coefficient of x in the equation? They are the same numbers, and let me write this properly. They are the same numbers. And we can see that because if we go back, the slope and the coefficient, they're the same, 2 and 2. Same and same, 1, and there's always an invisible 1 here, so they're the same. So that proves number 2. So number 3 says, how does the slope be found in each linear equation relate to the steepness of the line? So the greater the slope, considering absolute values, the steeper the line. So we can see that because since 4 is more greater in slope, the line is more steeper because C's line is more steeper. 1 is the least in slope and its line is not that steep, as you can see, if you compare A and C. So that proves number 3. So let's move on to number 4. Number 4 wants us to write an equation of a line that is 4a, steeper, increasing that then y equals 3x. So an equation of that would be y equals 4x because it's increasing, so it has to be positive, and it's steeper, so it has to be in greater value than 3. So I just chose 4. Let's see 4b. 4b wants us to do create an equation of a steeper line that's decreasing, then y equals negative 6x plus 2. So let's keep the y-intercept the same, and since we want it more steeper but decreasing, we can make it negative 7. So let's move on to number 5. Number 5, let's see what it wants us to do. Jordan and Alex disagree about the following 2 graphs. Jordan feels that the line on the left graph, which is this graph, is steeper, while Alex feels the line on the right graph is steeper, so this graph. Which line is steeper? Justify your response to Jordan and Alex. So this one is steeper because this line is closer to being vertical, and plus the slope of this is greater than the slope of this line. So that's why Jordan is correct while Alex is wrong. So let's move on to the next page. Let's move on to page 153, activity 12, lesson 12-2. So let's do the check your understanding. So number 6, let's see what it wants us to do. Write an equation of a line that has a slope that is greater than 1 but less than 2. So a slope greater than 1, less than 2, 1.5. And then you can just do a y-intercept of any value you want. So my equation I wrote was y equals 1.5x plus 2. So let's move on to number 7. Number 7 says, graph the equation y equals 3x. State the slope of the line. So we know that this is the slope. So slope of the line is 3. And I just kind of graphed this equation. I just did a sketch. So you can just sketch like that. You don't need to perfectly graph this. So number 8. It says the graph, table, and equation below represents 3 different linear relationships. Which one of the following has the greatest rate of change? Justify your response. So, this has the rate of change of 0.5. This has a rate of change of 3. And this has the rate of change of, let me see. This has the rate of change of 1. So, by this, we can calculate that this has the highest rate of change. So, the table we should circle. And you can justify your response by calculating the slope of each. And if you can do mental math, that's great. So, let's see number 9. Number 9 says, for each linear equation table below, complete a table value. So, we need to complete this. A graph on the grid provided using different colors. If you don't have different colors, just label your lines and determine the slope. This is just like what we did in the previous page over here. So I'll do it again with you guys. So by this, we can determine the slope of the line is -1 because there's always an invisible 1 here. So the slope is -1. Over here, we can see the slope is -2. Over here, we can see the slope is -4. And you could create the table of values by putting the values of x in the x right here, substituting them in. Same for b and a. And then you can graph the equation by this table of values. So let's move on to number 10. Number 10 says, how do the slope you found relate to the coefficient of x in the 3 equations? They're the same because -1, -1, -2, -2, -4, -4. So you see they're all the same. So let's move on to the next page. And the next page is 154, lesson 12-2, activity 12. So this is the activity practice. So let's see number 11. Number 11 is the same as number 1 that we did on page 151. So it's the same as this. Plus, it's the same as number 9. So, I'm pretty sure you guys can do this on your own, but I'll just go through this with you guys. So, we can find the slope because this is our slope. And then, we can also do this thing by putting the value of x in here, like they modeled it for us. They put -3 here, and then they found the y value. So you can put -2 here, find the y value, and so forth. And then and then also you can use this graph to do the table of values. Let's move on to number 12. Number 12 says the table and the equation below represent different linear relationships. Which one of them has the greater rate of change? Explain your reasoning. So this is just like the problem we had on the previous page, 153, number 8. Except that this does not have a graph. As you can see, this only has a table and equation, while this had a equation, table, and a graph. So we don't have a graph in that thing. So, and then you can calculate for this, the rate of change is 4, while for this, we have the rate of change is 3. So the table is our answer. So let's see number 13. Number 13 says, how does the slope of the line relate to the steepness of the line? So we know that the more the absolute value of the slope, the steeper the line. So let's see number 14. Number 14 says, given the equation below, how can the steepness of the line be determined without graphing? So we can know that by the coefficient of x. And let's see. Without graphing. So and then we can know that line A is going to be steeper because its coefficient is an absolute value greater than the coefficient of negative in absolute value. So that's how we can determine. Number 15 wants us to graph each equation. So this is my first equation, my second equation, and my third equation that I graphed. So we could see that, and then this is my first equation. second, and third. So we can see our first, which is the greatest, is the most steepest also. So let's move on to 15a. 15a says state the slope of each equation. So the first slope is 1/2 and 1 and 2. So let's move on to 15b. 15b says which line is steepest? Justify your response using the slope. So we know that this is the steepest because this slope is the greatest among all the slopes. So let's move on to the next page. So we're on page 155, activity 12, lesson 12-3. So let's read this part and then we'll move on to number 1. The slope-intercept form of a linear equation is y equals mx plus b, where m is the slope of the line and b is the y-intercept. We already know this from our previous videos, and I explained this to you before in the beginning of the video. So let's go to number 1. Number 1 says for each linear equation below, make a table of values, graph on a blank grid like the one below using different color for each line. You don't have to do that. You can just label which line is which. Determine the slope and the y-intercept. So we did the exact same problem, almost the same problem right here for this. So you guys had practice on this problem, plus you guys had practice on this problem. So I want and this problem. So I want you guys to do this on your own, because in lesson 12-2 over here, you guys had 3 times you practiced it. So I want you guys to practice here. So we'll move on to the next page, which is page 156, lesson 12-3, activity 12. So number 2 says, the equation and the graph below represent different linear relationships. Identify the slope and the y-intercept of both linear relationships. So we can know that how to find a y-intercept. So the y-intercept of this is going to be 0, -3, and over here it's going to be 0, 4. And the slope of this is going to be half, and you can figure out the slope by just by getting 2 points on the line and do that. So you can do number 2 on your own because you had a lot of practice. So let's move on to number 3. Number 3 says for each linear equation below, make a table of values in the minus section. The minus section is right here where you're going to make the table of values. Graph using a different color for each line. You don't have to do a different color. You could just label your line and determine the y-intercept, determine the slope. We did that in the previous page, number 1, and 3 times on lesson 12-2. So you guys have a lot of practice with this type of problem. So I want you guys to do this on your own. So let's move on to number 4, which is on the next page, and the page number is 157, activity 12, lesson 12-3. So number 4 says, how is the y-intercept related to the constant term in the equation you just graphed? Well, the y-intercept and the constant term is the same. We know that because the previous times we did that, we found out that it's the same. Explain how to graph a line using the slope and y-intercept. Well, you can graph the y-intercept first, and then you can use the slope to graph more lines, more points, and then you can do a line. So that's how you can answer number 5. Number 6 wants us to identify the slope and the y-intercept in each of the following equations. So we know that this is the slope, and 0, 5 is our y-intercept. We know that -1 is our slope, and 0, 1 is our y-intercept. We know that 4 is the slope, and 0, -3 is our y-intercept. So this is pretty easy. So you guys also know how to do this. So let's check your understanding right here. So let's read number 7. Number 7 says, make a table of values and graph the equation y equals -3x plus 2. State the slope of the line, give the coordinates of the y-intercept. So we know how to make table values. We did that in item 3 right here and item 1 right here on page 155 and 3 times on lesson 12-2. So you guys know how to do the table values, graph the equation, and slope, you can figure it out. It's -3, and the coordinates of the y-intercept is going to be 0, 2, because this is a positive 2, so we have to put a 0 here, so 0, 2. So let's move on to number 8. Number 8 says write the equation of the line graph. So first we find out the y-intercept is 0, 0. So we don't write the y-intercept. And then we see that, so we find the point. So we find 2.3 and -2 and 6 and -4. So we see that this is going negative. So we have to do y equals negative, and then we put an x, and this is where we put our y-intercept. So let's do change in y or change in x. So -4 subtract -2 over 6 subtract 3. So this is our change in x over here, change in y over here. So we find out plus is positive, so -2 over 3. So this is our slope. We put the slope over here, and we find this is the equation of our line. Okay, and so let's go to number 9. Number 9 says, graph each of the following linear equations using y-intercept and the slope. I already told you how, in number 5, how to graph equation using slope and y-intercept. Use the same thing what I told you here to graph these three, and then, yeah. So let's move on to number 10. Number 10 says, write an equation for the line graph below. Well, in number 8, we did the same thing. So you probably have practiced with one at least type of this problem, which is in number 8. So I want you guys to do number 10 on your own like we did number 8, using the same steps we did for number 8. So let's move on to number 11. Number 11 says, explain 2 different ways to graph a linear equation to form y equals mx plus b, where m and b represent any real number. Well, we learned so much about slope and so much about graphing linear equations. You should be able to know how to do this on your own. Plus, there are lots of ways that we already did this, so you can do this on your own. So let's move on to the next page. And that page is page 158, lesson 12-3 and activity 12. So we're on lesson 12-3 practice right now. So yay. So number 12 says, graph each of the following linear equation, state the slope, y-intercept for each. Well, you can graph the linear equations. Plus we know that the slope is this, and the y-intercept is going to be this. So this is pretty easy. We did that a lot on the previous questions. So you can do this on your own. So number 13 says, what is the slope of the graph of y equals -2x plus 6? So we know that the slope is going to be -2 because the coefficient of x is our slope. So -2 is going to be our slope. So -2, we see that this is, for these values, C is right. So for 13, the answer is going to be C. Let's move on to number 14. Number 14 says, what is the y-intercept of the graph of y equals 3/5 x subtract 12? So we know that the y-intercept is going to be something related to -2, -12. So, and then we also know that the x is going to be 0, so 0, -12. So we see that in option A. So we circle option A. So 14 is, the answer is option A. Let's see 15. 15 says, graph each of the following linear equations, state the slope and the y-intercept. This is the exact same problem that's up here in number 12, except it has different slopes and y-intercept. So I want you guys to do this on your own because you already had practice with one of these problems like this. So let's move on to problem number 16. So problem number 16 says, write the equation and the line graph below. So first, we can find out the y-intercept. So the y-intercept is going to be 0, so you can add the 0 if you want to or not, but I don't like to add the 0, so I'm going to do another equation. So, and then you can figure out that it's 3, this is 1 point, and this is 1 point, and then you can do a change in y, and this is the same line that in the previous page is right here. So in this page, we see this is the same question, number 8, as in 157, as it is in number 16. So it's the same question, and over there we found out this is the equation. So this is a good equation for the same thing because the problem is exactly the same. They just repeated it again in this to give you more practice. So let's move on to number 17. Number 17 says, Celso is reading Luz Lowry the Giver, which is 118 pages long. Celso reads 30 pages on average each hour. To model the number of pages he reads over time, A, create a table of values. I did that, and you can do that on your own because we had a lot of practice with this in many previous problems. And 17b says construct a graph. You can do that because we had a lot of practice with that also in previous questions. And number 17c says write an equation. Our equation is going to be y equals 30x. Or if you want to do that, or actually you can do, if you want to do a more complex equation, you could do y equals 180 subtract 30x. It has a specific range. So any of these equations are fine. It's just what your what depends on your teacher. And 17d says state the meaning of the slope and the y-intercept of the equation you are in part C. Well, if you had these, they're two different. So, well, for this, the slope is going to be 30, and the meaning is how many pages you're going to read in 1 hour. And the y-intercept is going to be 0 because you're starting with 0 pages. You haven't read any pages. Well, but if you do this, the slope of this is going to be negative 30, and that's how many pages that are cut from reading each hour that you read. Each hour, how many pages that are cut, and y-intercept is going to be how many pages you have to read in total of the book. So next we're going to be going to next page, and yeah. So we're on page 159, activity 12, and we're on activity 12, practice. So let's read the problem situation before starting. The problem situation is Owen found that he could use the equation y equals negative 3x plus 24 to model the amount of water in ml in his bottle after x seconds. So number 1 says, what is the slope and what does it represent in this problem situation? Be sure to include units. So the slope we know is negative 3, and it shows the water decreases by 3 ml every second. And number 2 says, what is the y-intercept and what does it represent in this problem situation? Be sure to include units. So the y-intercept is 0,24, and it shows the water starts with 24 ml. So let's move on to problem 3. Problem 3 says, explain to Owen what would have happened to the bottle for the slope to change to negative 4. The water in the bottle would leak more quicker or faster. Let's go to problem number 4. Number 4 says, the line with a slope of negative 2 goes through the point 3,5. It also goes to the point negative 2p. What is the value of p? Well, you can find the value of p equals to negative 15 by plugging in 15 and seeing it works, or you could find out the equation and plug it in the equation. You can do anything that works for you. So let's go to problem number 5. It says a line with a slope of 3 goes through the point negative 2, negative 4. It also goes through the point 0p. What is the value of p? It's kind of the same thing as number 4, except there's no solutions given to you. You can find out by deriving an equation and putting 0 as the value of x and finding y. And then basically your y is the p. So let's move on to number 6. Number 6 says, find the slope of the line that passes through the data points in the table. So we can calculate the slope by this. So since this right now it's a 1, and since this is 1/3, so this slope, we would have to times this by 3, and that will give us a slope of 3. So that's the answer to B. So let's move on to number 7. Number 7 says, what would happen to the slope of the graph of y equals 2/3 x subtracted the line shifted 6 units up? So 6 units up, that means, what happened to the slope? The slope would stay the same because only the y-intercept would change because the line is traveling up, and so up means the y-intercept would change. Nothing would happen to the slope. Let's go to problem number 8. Number 8 says, explain how the slope of y equals negative 2x subtracted can be used to graph the situation. So we can use this because we can plug in any value of x over here and then graph it on the equation. So for every coordinate, you can move 2 units up and 1 right. So by vertical, by horizontal change. Number 9 says compare and contrast the slopes for equation y equals x, y equals 1/3 x, and y equals 2/3 x. What conclusions can you draw by the slope of the lines? Y equals x has the steepest slope in the equation because it has the most slope value than these two. So number 10, let's move on to number 10. Number 10 says, write the equation of the line that is steeper than the line y equals a half x, where it has a slope less than 1. So I chose a slope of 3/4. So my equation was y equals 3/4 x. Well, you can choose any value between a half and 1, and you can derive an equation. Let's go on to number 11. Number 11 says, write the equation of the line graph below. Well, we know the y-intercept is 0, 0, so you don't need to write 0. And we know that, then we know for 3, this is 1 point. So we can do change in y or change in x. So our change in y is 1 subtract 0, and a change in x is 3 subtract 0, and that gives us it 1 over 3, and that's what I did here. So let's move on to number 12. Number 12 says, two graphs are given below representing different linear relationships. Which line has the largest slope? Explain your reasoning. Line 1 has the largest slope because it is more closer to being vertical than line 2. So let's move on to number 13. Number 13 says, what is the slope of each line in item 12? Explain the steps you use to find each slope. Well, the slope of this line is 2, and the slope of this line is 2/3. And what I did is right over run, so I chose 2 points, and I did the right over run or change in y or change in x, and then I found the slope of that. So let's move on to number 14. Number 14 says, identify and plot the y-intercept of the equation, y equals 1/3 x plus 3. So I identified the y or intercept is 0, 3, and then I can plot it really easily if I have a graph, but you can do that on your own. I'm not going to do that. We had a lot of practice graphing. Then use the slope to determine and graph 2 more points on the line. We did that before in the previous problems, so you can also do that on your own. Finally, sketch a line through the 3 points. You can also do that on your own. You just need a ruler for the last part. And let's move on to number 15. Number 15 says, explain how to graph the equation y equals 2x subtract 3 without using table values. First, you can graph the y-intercept, which is 0, 3. Then you can go 2 units up and 1 unit right for each coordinate after. Or you can go 2 units down and 1 to the left. Anything you prefer. So let's move on to the next page, which is page 160, activity 12, and we're still on the activity practice, and it's continued. So let's move on to number 16. Number 16 says, use the y-intercept and the slope to graph the following linear equations on the graph provided. Use different colors for each graph. You don't need to use different colors. Like I labeled using the equations. You can do the same, or you can just label A, B, C. Anything you prefer. But the teachers nowadays, they prefer you to use the equation to do it because you can mix up with the ABCs. So then you can graph these equations on your own because you already had a lot of practice at graphing. So let's move on to 17. 17 says, write an equation for the line graph below. First, you can find out what the y-intercept is, and then you can choose 2 coordinates and then find out the slope by changing y over changing x. That's how you can solve number 17. So let's move on to number 18. Number 18 says, identify the slope and the y-intercept for the graph below. So we can identify the y-intercept as 0, -5 because it's right here. And you can find the slope the slope is actually 3/4. You can find that out by choosing 2 points and seeing the change in y or change in x, like we learned how to calculate slope. So let's go to number 19. Number 19 says the graph and the equation below represent different linear relationships. Identify the slope and the y-intercept of both linear relationships. So we know the slope for this is 1/4, and the y-intercept of this is 0, 2. This is pretty easy. So let's move on to the graph. So the graph, we can know that this is our y-intercept. So our y-intercept is 0, -2, and our slope is 3 because you can choose 2 points. You can choose this point and you can choose this point, and you can see the change in y or change in x equivalent to 3. So thank you for watching this video, and in our next video we're going to be doing activity 13 of SpringBoard Course 3.